This is Euclid Book 10, proposition number 25. Look at that monstrosity. So what we've got here is a square, a rectangle, a smaller square, another rectangle, another square, and another rectangle. A, D, B, C, O, E, F, G, H, M, K, N, and L. That's what we've got. Okay, let's get into this. Euclid says, the rectangle contained by medial straight lines commensurable in square only is either rational or medial. For let the rectangle AC be contained by the medial straight lines AB, BC, which are commensurable in square only. So first we have to start with a rectangle called AC. Well, there's your rectangle, and it is contained by AB and BC. Okay? And there is no number that will divide this and this, but there is some square area that will divide the square area of this and the square area of this. So in other words, if you turn this line to a square area and you turn this line to a square area, there's some square area that will measure them both. We've covered that many, many times. Okay. I say that AC is either rational or medial. For on AB and BC, let the squares AD and BE be described. Okay. So what are these squares? Well, here's AD. This is the square area AD, okay, and this is the square area BC right here. That's what we've drawn. Okay. Therefore, each of the squares AD and BE are medial. Okay? So this area is medial, so is this. Okay. Let a rational straight line FG be set out. Okay, so now we're going to draw a rational straight line. And this rational straight line is going to be called FG. There it is. Okay. To FG, let there be applied the rectangular parallelogram GH. Okay. And GH is going to be equal to AD. Okay. So, we're going to form this rectangular parallelogram, and it's going to be this right here. And this area is going to be the same amount of area that you can find in this square. Okay. And of course, FH is the breadth of this rectangle. Okay? So far, so good. To HM, we're going to apply a rectangular to HM, let there be applied the rectangular parallelogram MK equal to AC. Okay? And we're going to produce HK as the breadth. So, we're now going to form MK. This is MK, and we're going to say that the area in here is equal to the area in here. And then we're going to say that HK is the breadth. And we're going to apply to Kn. We're going to apply a rectangular parallelogram. And this was going to be known as NL. And it's going to be equal to BE, producing KL as its breadth. Okay. So this area is going to be the same as this area, and this is going to be the breadth of this area. So far, so good. Now I'm losing some of my diagrams, so let me just adjust this a little bit. Okay. Now we've got that. All right. Therefore, FH, HK, and KL are in a straight line. So this line and this line and this line are all part of a line called FL. That's what it's all about. As a matter of fact, FH, HK, and KL are 3 parts of a line known as FL. And FL only had 3 parts, so there you go. Since then, each of the squares AD and BE is medial, and AD is equal to GH. Okay. So now we've established these are medial, and we've also established that AD is equal to GH. Okay, so now we can say that, sorry, this one is equal to this one. Okay. This one is equal to this one. We got that now. And now we can also say that BE and NL are equal. So the area in here is equal to the area in here. We can now say that. Therefore, the rectangles GH and NL are also medial. So this is medial, and so is this. We can now say that. And they are applied to the rational straight line FG. Okay. So, both of these were applied to the rational straight line FG. We can say that now. Therefore, each of the straight lines FHKL is rational and incommensurable with the length of FG. So, this line here and this line here are incommensurable with this line here. We can say that now. And we can say this because of Euclid Book 10, proposition number 22. And since AD is commensurable with BE, therefore GH is also commensurable with NL. Okay. So as this is commensurable with this, so is this commensurable with this. We can now say that. Okay. And as GH is to NL, as that one area is to the next one, so as FH is to KL. So, as... Now we got this. So as this area is to this area, so as this line is to this line. That's what they're saying, and this is by Euclid Book 6, proposition number 1. Okay. Therefore, FH is commensurable in length with KL. This is by Euclid Book 10, proposition number 11. Okay. So there is some number that will be able to measure both this and this. That's what he's saying. Okay. Therefore, FH and KL are rational straight lines commensurable in length. Therefore, the rectangle FH and KL is rational. So, if we were to form a rectangle and two sides of that rectangle were going to be the length of FH and two sides of that rectangle were going to be the length of KL, then that whole rectangle would be rational. And that's by Euclid Book 10, proposition number 19. And since DB is equal to BA, okay, and OB is equal to BC, so now we're talking about lines here. So we're now saying since this line length is equal to this line length and this line length is equal to this line length, we're destroying my diagram again. Since we can say all of that because they're sides of a square, therefore as DB is to BC, so is AB to BO. As this is to this, so is this is to that in a ratio. Okay. But as DB is to BC, so is DA to AC. Okay. So as this line is to this line, so as this area is to this area. That's what he's saying. Okay. Sorry, I had to make sure. And this is by Euclid Book 6, proposition number 1. And as AB is to BO, so is AC to CO. So as this line is to this line, so as this area is to this area. That's what he's saying. And this is also by Euclid Book 6, proposition number 1. Therefore, as DA is to AC, so as AC is to CO. So as this is to this, so as this is to that. They're all in a good ratio. Okay. Now, I was talking about areas, okay? In case you weren't paying attention, as this area is to this area, so as this area is to this area. That's what it was saying. That's what Euclid was saying anyway. But AD is equal to GH. Okay? So this area is equal to this area. We've already established that. AC is equal to MK. So now we have said that this area here is equal to this area right here. Okay? and CO is equal to NL. We now can say that this area here is equal to this area right here. Okay. Therefore, as GH is to MK, so as this area is to this area, so is MK to NL. So as this area is to this area, so as this area is to this one. That's what Euclid's saying. Okay. Therefore, also, as FH is to HK, so is HK to KL. And this is by Euclid Book 6, proposition number 1, and Euclid Book 5, proposition number 11. So as this line is to this line, so as this line is to this line. Okay. Therefore, the rectangle FHKL, okay, is equal to the square on HK. So now what he's saying is that if you formed a rectangle and two lines of that rectangle are FH and two lines of that rectangle are KL, then the area contained by that would be exactly the same area as if you took HK and formed a square out of it. In other words, you had all four sides of the square the length of HK. That's what he's saying. Okay. And this is by Euclid Book 6, proposition number 17. But the rectangle FH and KL is rational. Okay, so the rectangle you've now formed with two lines being the length of FH and two lines being the length of KL, it's a rational rectangle. Therefore, the square on HK is also rational. So if you have a square and all four sides of the square are equal to the length of HK, that area is also rational. Therefore, HK is rational. And if it is commensurable in length with FG, okay, so if HK, if the length of HK is commensurable with the length of FG, so in other words, if they say that there's some number that can measure both HK and FG, alright, HN is rational. So, in other words, if this is commensurable in length with this, then we can finally say that this area is rational. It's rational. This one's rational. The whole area. And this is by Euclid Book 10, proposition number 19. But if HK is incommensurable with FG, in other words, if there is no number that will measure HK and FG, okay, then KH, HM are rational straight lines commensurable in square only. Okay. Okay, so now we're going to say that these two lines are rational. This line here and this line here, they're rational, but they're only commensurable in square. Okay, so if you made a square out of HM and you made a square out of HK, their two areas would be commensurable. However, HK and HM are not rational. Okay, and so that means that HN would be medial. So that means that that area would be medial. Okay. And that's by Euclid Book 10, proposition number 21. Therefore, Hn is either rational or medial. But Hn is equal to AC. Okay, so now we've already said that this area is the same as this area. Therefore, AC is either rational or Therefore, this is either rational or it's medial. One or the other. Okay, and that is the whole proof. I will tell you more in a future video. Stay tuned.